This video will teach you how to solve quadratic equations using the quadratic formula. So if we take a look at example 1, when we solve this equation, we can first see if it could be factored. So remember from chapter 6, to solve this equation using factoring, we have to make the equation equal 0. And then we can see if anything multiplies to 8 and adds to negative 6. So negative 2 and negative 4 would multiply to 8 and add to negative 6. Then we set each factor equal to 0, and we would get our solutions. So yes, you can still factor if it's possible. If it's not possible to factor, you can complete the square as you learned in the 9.1 videos. So this is just a third way to solve a quadratic equation, so an equation with a highest exponent of 2, using what we call the quadratic formula. So I'm going to go ahead and redo this problem using this formula here. So this is a very common formula you're going to need for the rest of your math classes. So this would be a good thing to memorize. I'd write it over and over again, and most of you will probably memorize it by using it over and over again in this chapter. So to use this formula here, step 1 is very important. You have to write the equation in standard form. Once the equation is written in standard form, remember what that means. It means this. When the equation equals 0, then you can set the equation equal to 0 to get it into standard form, and then once that happens, then you can substitute into the formula your A, B, and C. So let's go ahead and do that. So step 1, we have to add 8 to both sides to get it into standard form. So that was step 1, make it equal 0. Then step 2, you're going to take your A value, your B value, and your C value. So A is always the number in front of the x squared, B is always the number in front of x, and C is always the constant, the one without a variable next to it. So then to find out what number makes this equal to 0, it says x equals negative B. So we're going to replace this with negative 6 plus or minus, and then it says b squared minus 4, and then an a and a c next to each other means multiply, so we're going to go ahead and use parentheses for multiply, so 4ac, all of that, the whole entire thing, divided by 2 times a. Okay, so now it's just a substitution problem. Now all we have to do is evaluate this using our order of operations. So first of all, this means the opposite of negative 6, so this is going to make a positive 6. And then order of operations, we would do exponents first, so negative 6 times negative 6 is 36. And then we would do multiplication next, so we would take all 3 of those numbers and multiply them. Now, if you're using a calculator, make sure to enter this in as negative 4 times 1 times 8. And whatever the calculator says is what goes here. So it's negative 32 all over 2. Now we would simplify inside the radical. So 36 minus 32 is 4. Okay. Then when we get it down to this part where there are 3 numbers here, you always want to start with the radical and see if the radical can be simplified. So the square root of 4 is 2. Now since the radical is now gone because we were able to evaluate the square root of 4, then what we're going to do is we're going to do 6 plus 2 all divided by 2, and then we're going to do 6 minus 2 all divided by 2. And that's going to get us our 2 answers. So here we're going to get 8 divided by 2, which is 4. And that's the same thing we got over here by using factoring. And then over here, we're going to have 6 minus 2, which is 4, divided by 2 is 2. And that's what we got over here by factoring. So again, this is just another method if you have to solve an equation where the highest exponent is 2. So now we have factoring, we have the square root property, we have completing the square, and now we have the quadratic formula. So I see I'm missing step 3. Step 3 is we simplify. That's what we did here. Okay, so before we do any more problems where you're solving, I want to go ahead and just focus on this last step right here, because that's all that's new. I mean, you guys have been substituting numbers in for variables for a while now. You know how to use order of operation, but let's focus on this part when we get it to the end when there's 3 numbers. So let's pretend you do all the work and you're left with these 3 numbers. What would you write here on your answer blank? So again, as a teacher, this is what I see most people making mistakes on, and they lose points. So again, when you get it down to the 3 numbers, your focus should be on this first. Simplify it. So the square root of 49 is 7. So the radical's gone because I was able to answer what times itself is 49. Okay, then if the radical goes away, then you would just do 2 plus 7 divided by 9, and then you would do, negative 2 plus 7 divided by 9, and then you would do negative 2 minus 7 divided by 9. So we would get here 5/9 as one of the solutions. And then here we would get negative 9/9, and we would put negative 1 as our solution. So that is the answers I'm looking for if you got this when you get to this step. Okay, let's go ahead and check out another one here. So first step is to look at the radical. It looks like it's been simplified here. So then once you deal with the radical, nothing we can do here. Nothing times itself is 6. So then what you do is you ask yourself, does anything go into 6, 2, and 2? So we're going to ignore this square root of 6 and see if there is a number that goes into all 3 of them. So in this case, 2. So we're going to divide out a factor of 2 from all 3 of these. Not the 6, because the 6 is in the radical and it's not 6. It's a decimal. It's square root of 6. So you're going to divide everything by 2. So then we'd have negative 3 plus or minus the square root of 6, because there would just be a 1 right here, over 1. Well, anything divided by 1 is just itself. So we would get negative 3 plus radical 6, and we'd have negative 3 minus radical 6. And that is how we would write our 2 answers. Now, if this was a test, you can leave it as negative 3 plus or minus radical 6. Okay, let's go ahead and look here. So first thing we do is we simplify the radical. So we learned how to do this last chapter. We have to check and see if any numbers on our perfect square list can go into 18. So we know 9 does. So we need to go ahead and simplify it like you learned last chapter, either using method 1 or method 2, so the factor tree, or the perfect square method where I'm going to use 9. Square root of 9 times square root of 2 is 18, and then we would get 3 rad 2. So now I'm going to rewrite it with 3 rad 2. Okay, so that's the first step. You want to simplify the radical. Then you ask yourself, can anything go into all 3 of these numbers here, not the 2? And so since 3 goes into all of them, we'll go ahead and divide them all by 3. So we'd get negative 2 plus or minus the square root of 2. So again, if you put a 1 here, you don't need to, because 1 in front of a radical just means times. So our final answer would be negative 2 plus square root of 2 over 3, and then negative 2 minus square root of 2 over 3. Okay, let's take a look at another one here. So we do all the work, we get it down to this. We always focus on the radical first, and none of these numbers can go into 5. But since it's negative, there is no real solution. But because in this class we are allowed to work with the complex number system, or we're going to practice, I should say, we would write this as -5 plus or minus I rad 5. So again, we learned how to simplify radicals that were negative, or square roots, I should say, that are negative. We would make it positive by multiplying by a -1, and then our substitution is to plug an I in there. And the I can go second like this, or I prefer it in the front. So that's what I did right there, all over 2. Okay, so after we simplify the radical, we look in the front and we ask ourselves, can anything go into 1? Because there's nothing here, it's a 1, 2, and 5. So since nothing goes into all 3, that is how we leave our answer. -5 plus I rad 5 all over 2, and -5 minus I rad 5 all over 2. That's how we would write it out twice, or we would leave it like this if we were allowed to leave it as one fraction, even though that's 2 answers. All right, let's take a look at here. So first thing I'm going to do is focus on the radical, and I'm going to see if any of these numbers in our perfect square list can go into 15. And since none of these do, we're done with the radical. And now we have to look if anything goes into 5, and then the number in front of the radical is a 1. So anything that goes into 1, 5, and 10. And the answer is no, so we're going to leave it like it is. So this one could not be simplified. Okay, so again, it can't be simplified. Now, if you were thinking that the 5 and the 10, then you'd have to put the 10 underneath both of them and split them into 2. We're focusing, how do you leave them as one whole fraction? So that's why we're not simplifying these, because then I'd have to write it as 2 parts. So we're practicing leaving it all together. All right, let's take a look here. So we're going to see if 3 rad 5 can be simplified. And there is none of these numbers here that can go into 5. None of our perfect squares can divide into 5, so that's already simplified. So then we have to check and see if there's a number that goes into 4, 2, and 3. So there's no number that goes into all 3 of them, so this one also cannot be simplified. So can't be simplified. So we would just leave it as -4 plus 3 rad 5 over 2 and -4 minus 3 rad 5 over 2. So nothing will change.